For this video, I want to show you the calculations that you need to do for Part B, as well as how to take this data and then plot it also in Part B. One thing to note, whenever you first get a hold of a graph, pay attention to the X and Y axes. What is it asking for? So this is temperature. This is a solubility of potassium nitrate in 100 milliliters of water. If we look at that table, it's these two columns that it's talking about. So this is the x-axis data and this is the y-axis data. Now, the experiment that we did, and specifically, it was this one that we saw in the video. And in that experiment, I measured out about 5 grams of the sample, put it in 5 milliliters of water, and then we measured the temperature of that solubility. Now, we don't want 5, and I'll just use all the data here. We don't want to talk about 5 grams in 5 milliliters of water. What we want to talk about is what's the proportion between this ratio and the mass of the potassium nitrate to 100 milliliters. And it's this X that's going to go into the data table here. So when you work one of these, the phrase, sometimes you hear cross, multiply, and divide. That's one way to do this calculation. What it's asking for is the cross, multiply, and divide. What it's really doing is it's establishing the algebra that you need for this work. So if I cross multiply, so now 5 times x, there it is, and then that's going to equal to this 5.0266 grams times 100. And it's the first step in what's essentially the algebraic rearrangement to solve for x. That's what you're doing when you say cross, multiply, and divide. And then the divide part, I'll just go ahead and do it as one total setup here. What that means is that you're dividing by whatever value is associated with x. And the reason why you do that is simply because once you divide this side, so the divide part, whenever you do the algebra here, if you divide 5 milliliters on one side, you need to divide 5 milliliters on the other side. That maintains the equality in the expression. Okay, so on this side, if I divide by 5, all it's doing is it's getting rid of that original 5. Algebraically, it's like it's moving it over to the other side of the expression. And now you have a complete mathematical expression that you can plug and chug on your calculator to determine x. When you do that, you see that x is equal to 100.532. So whenever you're doing a calculation like this, you should factor in the sig figs with the calculation, okay? And in terms of the data that we have here, there's only 2 sig figs in the 5.0. That means we want to keep 2 sig figs in this answer. With the extra 0 there, what you have to do in this particular example is you need to convert it to scientific notation to really handle the proper sig figs. That means by 1, 2, moving the decimal over to 2 positions. Right? That 2 is really representing the exponent on the scientific notation. For this class, you will not have to do this very often. Okay, it just happened to fall that way in our math here, which is fine. When I actually graph in a minute, I'm just going to use 100, by the way. Okay, so that's the proportion calculation that you need to do for all of these. So to go from this data to your y-axis, you need to perform this calculation for each of the masses there. And again, when you do that, that is going to give you your x-axis for the data. Let's go plot that data. And notice one thing that's nice about Timberlake is that she went ahead and added in the numerical values for your graph here. And so, right, when you're working with a graph, let's see, what was it? It was 56.8. So that's the temperature. So 56.8, this is 50, that is 60, right? That's 70. So 56.8 is just past that 55 line. And so it's going to be about, we'll say about right there. And then, oh, well, it's 100 grams. Right. So it would be right there. So basically, you're just going up until those two data points intersect. And that's your first plot on the graph. And then what you'll do is that once you have all of these values plotted, then you'll use, again, x, y axis. And it's going to plot, and I'm just going to make this data up. It'll look something, solubility increases as you increase the temperature, which is what this is showing us. And then that would be your graph. And then you don't see it here, but there's questions below this graph that you'll actually answer based on this graph. And so one thing that you'll probably want to do is just go in here and just sort of connect the dots the best you can. Just sort of make it a smooth line. And then you can use that line, and then you can, like for example, now if I want to know the solubility of the potassium nitrate at 100 and, actually I should go the other way with this. Let's do, let's see, this is about 90 right here. So at 90 degrees, the solubility would then be, something about right here. And so that is, 160, 170, 180. So this is 180. Right, so once you have that smooth line connected through the data points the best you can, then you can make predictions about the other values with respect to solubility and temperature. And that's essentially what this part B is all about. Thanks.